So let's talk about this fun sample. This is part of a recent malware infection chain. This is the stage 2 of that. So the first stage ends up being a GUI application that the user then clicks a button that has the word patch in it. And it ends up prompting the user for their password. If they enter their password, it then runs this binary that we're going to look at with elevated privileges. All right. So the reason I want to talk about this one is because it allows me to talk about Objective-C, which is my favorite language to reverse. So let's get started. We're inside of the main function here. And the first branch and link instruction to call a function we see is Objective-C auto release pull push. So this is part of automatic reference counting, or ARC for short. And this is for object memory management in Objective-C. So we're just gonna label this. We don't need to worry about that too much here. So then we have this pair of instructions. So this is very common in ARM64 compiled binaries, where you have, or Mac OS, of course, where you have this ADRP instruction that loads a page that ends in 8000 into X8, and then we're calculating an offset from that page here. So this bracket is like an addition, since this is not a negative value. We have this address plus 180 hex. That ends up being the value after that calculation, ends up being saved into X0. And Binary Ninja is able to see that this is for this, an Objective-C class NS file manager. If we go here, we'll see that this exists within the Objective-C class references section. And yeah, so it's just a reference to this file manager. So that's used for like file operations, which is where we're going to see it used here. So then we have this branch and link to this Objective-C message send default manager. Okay, so for those that are not familiar with Objective-C, method calls are completed using this Objective-C message send function. And what it takes in as arguments is the class and then a selector, which is a string representation of the method that's going to be called. In this case, our method is for default manager. So if we go inside of here, we'll see how that works. So another ADRP LDR set of instructions to get the page, and then add 98 hex to that page, which ends up being this value here, which resolves to default manager. We can double click on here and see that this is inside of the Objective-C meth name section of the binary. So this is a string for default manager is loaded into X1. Then we have another set of ADRP to get this page and load the address into X16, and then this BR instruction does a branch to register, which branches to the address that's saved inside of this register. And then that ends up executing the default manager method for the file manager class. Okay, so this is another ARC related thing. Objective-C retain auto release return value. This is also part of ARC. So whenever you see this, just know that the return value of this call, this method call to default manager in this case, is going to be saved in X0, which is normal when it comes to ARM64 function calls. Okay, so ARM is a load and store architecture, so you're going to see a lot of storing and loading values to and from the stack. So here we have this STUR for this value that's inside of the X0 register, which is the return value of the default manager, right? After we ran that. And that is going to be saved at the address, the calculated address of whatever's in X29 minus 0x18. So we have our frame pointer and our stack pointer. This is calculating the space in between that frame for the main function, and it's storing this value there. So we can just call this default manager. And it's storing that because it's going to be used for other calls later on. Okay, so store, now load. We're going to do an LDUR of that into X0. And then we're going to end up calling this file exists at path method. But before that, we see this ADRP for this CFSTR, which is a CF string, that we have that same pair of instructions. Get the page plus 150. And if we look at this, we'll see that this is for a CF string, which is inside of the CF string section of the binary. And these are structs, right? So this NS constant string struct, and inside of here we have this data member, which is the string itself that we're concerned with, which is user local bin Python 3. If we look a little bit ahead, we'll see the homebrew path, we'll see an op local path, and a user bin path, all for Python 3. So this binary is looking to see if Python 3 is installed on the machine, and it's going to use 4 paths in order to check for that. Okay, so we're just working with the first path right now. And then we have this call to Objective-C message send file exists at path, which returns a Boolean value based on if the file exists or not. Okay, so let's talk about how this works. We have that same x1 value, x1 register being given the file exists at path string, and then we have this branch to the address for Objective-C message send. Now to talk about how this looks, if you were to write this in Objective-C and how ARM represents this, so x0 is going to be our class or reference to class. x1, these registers are going to be the selector, which is a string, and this is our method. Now x2 ends up being arg1 that gets passed to the method call. Now if the method accepts more than one argument, you keep passing them as through registers. So x4 would be arg3 and so on. This one only accepts one argument, so this is what it would look like if we were to write this. Something like this. So default m, right? And then we're going to do the file exists at path. Method names can be a little long, and this is not that bad. And then we have like a string representation for the argument. So user local bin Python 3. And that's how this would look in Objective-C. Okay. So add that comment, and that ends up executing this file exists at path, which returns a Boolean, and then there's a check for this, and you'll see that there's a check for each one of these paths along this chain here. And if it does not see it, right, so TBNZ test bit not 0 is checking that return value. The reason that W0 is used here instead of X0 for the return value is because this is going to be a 1 or a 0 depending on the return value, this Boolean, and you don't need to use a X register for that. You can just use the 32-bit equivalent of that register. So W0 is checking against that, and if it does not find it, then it continues, right? So we have this branch here that then goes and checks the next one, right? So we can see that in the decompilation a little bit. It's a little bit harder to see because we don't see the CF string representations here, but we have this huge if statement that's looking to see if it exists or not, these different paths. And if it does not find a match using this file exists at path method call, it then runs this install Python function. So we can see that here at the very bottom. So it branches and links to this install Python, and then it does something I think is pretty cool. So first, let's just start here. So this ends up getting an instance of this NS task, right? We have the same ADRP loading this reference to NS task. and it's doing an Objective-C alloc init, so it's initializing this. And we can see the CF string here. We're just going to bypass all this for a moment. This bin bash, right? So bin bash is going to be like the first set launch path for this task that we're executing. And then we have this call to sudo installer this CF string here. So the first binary in this attack chain, what it did was inside of the resources directory for the app bundle, it had this Python package that came with it. And it ended up moving this Python package to the temp directory prior to executing this tool binary that we're analyzing right now. So this ends up calling the sudo installer binary, passing the dash pkg argument and then the path to this package. And it then installs Python. And then from there, it does a bunch of other stuff, downloads scripts, and does what it needs to do and executes all this stuff. But first, what it needed to do was check to see if Python is installed, since that's not automatic on recent macOS systems. All right, so that's it. Just a quick, brief coverage of Objective-C because it's really cool to look at. Yeah, thanks.